Hello, this is group 8A and we'll be solving the second question of the third tutorial. Over here we're given a pin joint truss in which all the members are of the same length. Hence we'll have two equilateral triangles. First of all, we're going to identify the static indeterminacy of this structure. There are four unknowns, two arising from the horizontal and vertical restrictions in the first pin joint and another two from the second pin joint. There are also three equilibrium reactions, one of which is the sum of the moments is equal to 0 about any point. The sum of the forces in the x direction is equal to 0, and the sum of the forces in the y direction is equal to 0. Hence we have three equilibrium equations. The redundancy can be found by subtracting the equilibrium reactions from the unknowns. Here we'll have a redundancy of 1, which means that our structure is statically indeterminate.
As Mark said previously, we have a statically indeterminate structure. So to make this statically determinate, we're going to release the horizontal reaction at point C. When we release this horizontal reaction, there's going to be a displacement in the CB direction that way. So we're going to, and that displacement is shown by the red arrow going that way by F10. And this is K0, and for K0, this only comprises of the external loads on our truss structure.
Okay. Then now we introduce a new case 1, which is here. And then in case 1, there will be a horizontal force X1, which is the reaction force we released from the pin joint. And in this case, there will be a new displacement F11. The superposition of case 0 and case 1 will be our original structure. To find x1, we will have to imply unit load 1 in horizontal direction at point C.
Since the horizontal displacement at C in original structure has to be equal to 0, we apply this equation. And to find F10 and F11, we have the equation here, where N0 and N1 is the axial force in each member of case 0 and case 1, and delta 0 here is the elongation, which is also equal to 0.
To find F10 and F11, we first need to find the axial forces in case 0 and case 1. We find the axial forces in each individual member using the method of joints, which we learned in the first year. And we use the positive sign to denote a member in tension and the negative sign to denote a member in compression. To find F10, we can use the equation that was introduced before to find all the individual F10s in members AB, BC, CD, AD, and BD. And the summation of it will give the total F10. We can do the same thing for F11. And after finding F10 and F11, we can find X1, which is negative F11 over F10.
After finding the displacement, which is represented by F10 and F11, we can try to find X1, which is the force in displacement of the horizontal direction of at C. And to find X1, we divide minus F11 by F10, and we get this value here as the value for X1. Finally, to find the forces in each member in the truss, we multiply the value of X1 to N1K so that we could find the forces in each member in case 1. And to find the forces in each member in the whole structure, we superimpose the value of the forces in case 1 with the forces in case 0, so that we could find the forces in each member in the whole structure, the truss structure, which is represented by the values in this column.
Thank you for watching our video. This is group 8A doing tutorial 3 question 2. Bye.